Hello students, welcome to our class. In previous lecture we have started a new topic, indices. Okay, so in that topic we have discussed uh, indices. So here see, such types of numbers are called indices. We read it as 2 raised to 3. We can read it as 2 raised to 3. In this number 2 is called base and 3 is called power, or we can say index. Okay, and after that we have also discussed that how to find the values, means if we have this 2 raised to 3, then how to find its value. So 2 raised to 3 means multiply 2 by itself 3 times, 1 2 3. So here 2 raised to, value of 2 raised to 3 is 8, and we have solved such types of examples. Okay, after that we have discussed how to find square and cube of number. So what is the square and cube? So square of number means what? Square means what? If the power is 2, means see here, if 3 power of 3 is 2, so we can read it as 3 square. Power here for power of 3 is 2, so here we shortly read it as 3 square. Okay, and we know if power is 2, then we multiply 3 by itself 2 times. Okay, and here we get 9. So 3 square is 9, or you can say square of 3 is 9. And I have told you in previous lecture, find the squares of numbers from 1 to 50. Okay, square. And what is mean by cube? So cube of number means what? If the power of number is 3. Okay, see here power of 4 is 3, so we can read it as 4 cube. We can read it as 4 cube or cube of 4. So here what is the 4 cube? 4 cube means multiply 4 by itself 3 times. Okay, so it gives 64. So here 4 cube is 64. Okay, so if the power is 2, then we call square, and if the power is 3, we can call cube. Okay, and I have also told you to find cube of numbers from 1 to 50. Okay, now let us move toward the next point, that is multiplication of indices. Multiplication of indices with same base. With same base. Okay, now see, take one example. Multiplication of indices means, see, with same base. So I have take 2 raised to 4 multiplied by 2 raised to 3. See here, these are the indices 2 raised to 4 and 2 raised to 3. Multiplication, their multiplication, and see, they have same base. Here base of this index is 3, base of this indices is also, sorry, base of this indices is 2, and base of this index is also 2, so their base is same. Okay, so multiplication of indices with same base. Now see how what we get result from this. So here you can multiply. So here first of all 2 raised to 4 means what? 2 multiply by itself 4 times. Okay, 1 2 3 4 multiply. Here 2 raised to 3 means what? 2 multiply itself by 3 times, 1 2 3. Okay, now see here how many times 2 occurs? 1 2 3 4 5 6 7. So here 2 is multiplied by itself 7 times, so we can write here 2 raised to 7. Okay, so here see, we got result 2 raised to 4 into 2 raised to 3 is 2 raised to 4 plus 3, that is 2 raised to 7. See here 2 raised to 4 into 2 raised to 3 means 2 raised to 7. So here 4 into 4, 2 raised to 4 into 2 raised to 3 means 2 raised to 4 plus 3, that is 2 raised to 7. Okay, again see one more example. Minus 3 raised to 2 into minus 3 raised to 3. Now see here, multiplication of these two indices. See, their base is same, minus 3 minus 3. Now see, minus 3 raised to 2 means what? Multiply minus 3 2 times. Okay, 1 2, this multiplication sign. Now here minus 3 raised to 3 means what? Multiply minus 3 how many times? 3 times. Now see, here minus 3 is multiplied by itself how many times? 1 2 3 4 5. So we can write minus 3 raised to 5. Okay, now see what we have got. Minus 3 raised to 2 multiplied by minus 3 raised to 3 is equal to minus 3 raised to 5. That is, see here, minus 3 raised to 2 plus 3, minus 3 raised to 2 plus 3, minus 3 raised to 5. Again see one more example. Suppose we have product of indices. See, minus 2 by 5 raised to 2 is multiplied by minus 2 by 5 raised to 3. See here, their base are same, minus 2 by 5, minus 2 by 5. Okay, now see here, minus 2 by 5 raised to 2 means what? Multiply minus 2 by 5 by itself 2 times, 1 2, this multiplication sign. Again minus 2 by 5 raised to 3 means multiply minus 2 by 5 3 times. Okay, now see, again minus 2 by 5 occurs how many times? 1 2 3 4 5. So here minus 2 by 5 is multiplied by itself how many times? 5 times. So here see, minus 2 by 5 raised to 2 multiplied by minus 2 by 5 raised to 3, that is nothing but minus 2 by 5 raised to 2 plus 3, that is minus 2 by 5 raised to 5. See, means here we got result multiplication of indices with same base. See here, if the multiplication of indices with same base, okay, see here, these two indices have same base a, then what happen? Their base remains same and power gets added. Okay, so a raised to m into a raised to n is nothing but a raised to m plus n. Means if there is a multiplication of indices with same base, then what we will get? Their base remains same and power gets added. Okay, means you can apply this property in example. Suppose we have a raised to see 7 raised to 4 multiplied by 7 raised to 2. Okay, so you can write this term in short form. See here, base remains same, power gets added. So here 7 raised to 6 means, see, 7 raised to 4 multiplied by 7 raised to 2, you can shortly write it as 7 raised to 6. Base, if base same, then power gets added. In multiplication if base same, then power gets added. So 7 raised to 4 into 7 raised to 2 is nothing but 7 raised to 6. Okay, see one more examples. Suppose we have question, simplify. Okay, now see, first minus 11 raised to 5 into minus 11 raised to 2. So see, we know if in the multiplication of indices, if base is same, then base remains same and power gets added. So here what we will get? Minus 11 raised to 7. So see, we have simplified this term. Okay, minus 11 raised to 5 into minus 11 raised to 2 is nothing but minus 11 raised to 7. See here, 6 by 7 raised to 3 multiplied by 6 by 7 raised to 5. So again see here, base are same, 6 by 7, 6 by 7. So base remains same, power gets added, 3 plus 5, and it's nothing but 6 by 7 raised to 8. So you can simplify this term. Okay, see here, p by 5 raised to 3 multiplied by p by 5 raised to 7. Again see, there is a multiplication of indices with same base, p by 5, p by 5. So if the base is same, then base remains same and power gets added, 3 plus 7, that is p by 5 raised to 10. Okay, see one more example, a raised to 16 multiplied by a raised to 7. Again see here, base is same, there is a multiplication, so base remains same, power gets added. So here we get 23. Okay, so a raised to 16 multiplied by a raised to 7 is a raised to 23. Okay, so by this property, what property? A raised to m into a raised to n is nothing but a raised to m plus n. Okay, so we can simplify the terms. Now let us move toward the next point, that is division of indices. Here we have discussed multiplication of indices with same base. Now what happen in division of indices with same base? Okay, division of indices with same base. Suppose we take two indices, 6 raised to 4 divided by 6 raised to 2. See, there is a division of indices with same base. Here their base is same, 6 6. Okay, so division of indices with same base. Now see, we know. Now see what result we will get here. So 6 raised to 4 divided by 6 raised to 2, we can write it as 6 raised to 4 upon 6 raised to 2. Okay, division. Now solve it. 6 raised to 4 means what? Multiply 6 4 times. 1 2 3 4 upon 6 raised to 2 means what? Multiply 6 2 times. Okay, now again see here, this 6 6 get cancels. So what remains? 6 multiplied by 6. So 6 multiplied by 6, 6 multiplied by itself 2 times. So you can write it as 6 raised to 2. So see here, 6 raised to 4 divided by 6 raised to 2 is 6 raised to 2. Means see here if the base is same, then see here power gets subtracted. 4 minus 2, that is 2. Okay, here whenever their base is same, in multiplication if base is same then power get added, and here in division base is same then power gets subtracted. So here bigger power, small power is get subtracted from big power. Here 4 minus 2 is 2. Again see one more example. Minus 2 raised to 5 divided by minus 2 raised to 3. So see here, we can write it as minus 2 raised to 5 upon minus 2 raised to 3. So minus 2 raised to 5 means multiply minus 2 by itself 5 times. Okay, 1 2 3 4 5 upon minus 2 raised to 3 means multiply minus 2 by itself 3 times. Okay, so here this 3 minus 2 get cancelled. What remains? Minus 2 multiplied by minus 2, and minus 2 multiplied by itself 2 times. So minus 2 raised to 2. So see here we got minus 2 raised to 5 divided by minus 2 raised to 3 is nothing but minus 2 raised to 5 minus 3, that is minus 2 raised to 2. See our answer. Okay, so here what result we have got? If the base are same in division of indices with same base, then base remains same and power gets subtracted. So big power minus small power. Okay, here 6 raised to 4 divided by 6 raised to 2 means 6 raised to 4 minus 2, that is 6 raised to 2. Here minus 2 raised to 5 divided by minus 2 raised to 3 means what? Minus 2 raised to 5 minus 3, that is minus 2 raised to 2. So here we got result that a raised to m divided by a raised to n, or you can write a raised to m as like this also. Okay, if there is a division of indices with same base, then what we will get? Base remains same, and here big power means m minus small power, that is n. If the base are same in division, then big power base remains same and power is m minus n. Okay, so you can use this property in examples. Okay, now see examples based on that properties. See here, suppose we have a raised to 6 divided by a raised to 4. So see, there is a division of indices with same base, so we know if the base is same, then base remains same, and here 6 minus 4, that is a raised to 2. So a raised to 6 divided by a raised to 4 is nothing but a raised to 2. Okay, now see, m raised to 5 divided by m raised to 2. So here m raised to 5 divided by m raised to 2 means what? M raised to 5 minus 2, that is m raised to 3. Okay, here x raised to 10 divided by x raised to 10. So here again base is same, so when base is same, then power here power is 10 minus 10, that is x raised to 0. Okay, now you can use this property. Now again see, there are some more results related to this property. Okay, now first result is, what is the value of a raised to 0, means whenever there is power 0. So see here, we have studied, if a raised to 1 is, means what, a multiply itself by 1 times. A raised to 2 means what, a multiply by itself 2 times. But we don't have discussed what does mean by raised to 0. A multiply 0 times, no, there is we can't take meaning of a raised to 0 as like this. So here, to find the value of a raised to 0, we use this formula. Okay, now see, we can write a raised to 0 as a raised to, we can write a raised to 0 as see here, before a raised to 0, see this result. What is mean by a raised to minus, sorry, okay, see here, we will ignore that. What is mean by a raised to 0? So see, we know a raised to m upon a raised to m is 1. Okay, we know, because when we divide a same number by itself, we get quotient 1. So here I have taken same number, a raised to m upon a raised to m. Okay, now see, by this property we know a raised, if the bases are same, then power gets subtracted. So here base are same, then here base remains same and power gets subtracted, means m minus m, that is equal to 1. So m minus m means what, 0. So here value of a raised to 0 is 1. See here, I have taken this. See here, to find value of a raised to 0, I have taken this. So we know, when we divide same number by same number, 2 by 2 is 1. Okay, so here I have taken the same number as a raised to m. So when we divide a raised to m by a raised to m, we got quotient 1. And by this property, when the bases are same, so here indice power gets subtracted. So here a upon m, a raised to m upon a raised to m means what, a raised to m minus m, okay, is equal to 1. And a raised to m minus m means a raised to 0, its value is 1. So C means, if we have 2 raised to 0, so 2 raised to 0 is 1. If we have 3 raised to 0, 3 raised to 0 is 1. 4 raised to 0 is 1. Minus 5 raised to 0 is 1. Means 0th power of any number is 1. So C, a raised to, sometimes we can we write a raised to 0 is 0. So this is wrong, because we multiply a 0 times. So see here, a raised to 0 means 1. So 0th power of any number is 1. Okay, so 2 raised to 0, 1, 3 raised to 0 is 1, 4 raised to 0 is 1. So 0th power of any number is always 1. So remember that property, a raised to 0 is always 1. Okay, so 0th power of any number is always 1. And we have to use this property in the examples. Okay, now see second property, what is meaning of a raised to minus m. Okay, so see here, we write a raised to minus m as a raised to minus m into 1, because when we multiply any number by 1, we get same number. Okay, so a raised to minus m can be written as a raised to minus m multiplied by 1. Again put this as it is, We know 1 means you can write a raised to m upon a raised to m. Again same number divided by itself, it gives 1. Okay, now see, we know how to multiply. Okay, so here a raised to minus m multiply by a raised to m whole divided by a raised to m. We know how to multiply number by fraction. Okay, now again see, there is a multiplication of indices with same base, here a, here a. So here whenever we have property a raised to m multiply by a raised to n is a raised to m plus n. So here a raised to minus m multiply by a raised to m is a raised to minus m plus m. When base is same in multiplication, power get added. So here a raised to minus m plus whole divided by this a raised to m as it is. So a raised to minus m plus m is 0 upon a raised to m, and we know by previous property a raised to 0 is equal to 1. So a raised to 0 is 1 upon a raised to m. So see here, we got result a raised to minus m is nothing but 1 upon a raised to m. Okay, now see, suppose we have 2 raised to minus 4 means what, 1 upon 2 raised to 4. So whenever we have to write this negative, see there is a negative power now, minus 4. So we can write this negative power in terms of positive power. See here, plus 4. So 2 raised to minus 4 can be written as 1 upon 2 raised to 4. See here, 1 raised to minus 5. So here 1 raised to minus 5 means what, 1 upon 1 raised to 5. Okay, see one more examples. Minus 2 raised to minus 3 means what, 1 upon minus 2 raised to 3. So whenever there is a negative power, so we can write in terms of positive power. So a raised to minus m is nothing but 1 upon a raised to m. So minus 2 raised to minus 3 means 1 upon minus 2 raised to 3. See next, suppose we have a raised to minus 1. So we have property a raised to minus m means what, 1 upon a raised to m. So a raised to minus 1 means what, 1 upon a raised to 1. Okay, so this negative power gets positive. So here 1 upon a raised to 1 means a. Okay, a raised to 1 means a. So here a raised to minus 1 is 1 upon a. Okay, so here a raised to minus 1 is called multiplicative inverse. So whenever there is negative power is 1, then we call it as multiplicative inverse. So we also know this is called reciprocal also. Okay, we know what is the reciprocal of a, or multiplicative inverse of a. Multiplicative inverse of a is 1 upon a. We know multiplicative inverse or reciprocal of a is 1 upon a. And see here, we got a inverse is equal to 1 upon a. A inverse is equal to 1 upon a. So here a inverse is multiplicative inverse of a. A inverse is called multiplicative inverse of a. Okay, now see, 2 raised to minus 1. So here 1 upon 2 raised to 1, that is 1 upon 2. Okay, so 2 raised to minus 1 is 1 upon 2. So here see, 1 upon 2 is multiplicative inverse of 2. So here 2 raised to minus 1 is multiplicative inverse of 2. Okay, so what properties we have got? A raised to 0 is 1, a raised to minus m is 1 upon a raised to m. Okay, and a inverse is called multiplicative inverse of a. Okay, now see what is our fourth property. So suppose to fourth property we take example. Find okay, so see here, 5 by 3 raised to minus 1 means multiplicative inverse of 5 by 3. So we know 1 upon 5 by 3 raised to 1. Okay, and 1 upon 5 by 3 raised to 1 is 1 upon 5 by 3, and that is nothing but 3 by 5. Okay, so here 5 by 3 raised to minus 1 is what? 3 by 5. Again see one more example. 5 by 3 raised to minus 2. So here I have taken power minus 2. Again by property 1 upon 5 by 3 raised to 2. Okay, so here 1 upon 5 square upon 3 square. Okay, now see here 3 square upon 5 square, that is 3 by 5 bracket square. Okay, so here 5 by 3 raised to minus 2 is nothing but 3 by 5 raised to 2. 5 by 3 raised to minus 2 is nothing but 3 by 5 raised to 2. In above example, 5 by 3 raised to minus 1 is 3 by 5 raised to 1. Okay, so here we got again one more result, that is C. If A and B are non-zero numbers, their power is minus m, is negative, then we can write in terms of positive. Okay, so here A by B raised to minus m means what? A by B raised to minus m means what? B by A. See here 5 by 3 gets 3 by 5, so A by 5 gets B by A, and here minus power get positive, so here minus m get plus m. So here A upon B raised to minus m is nothing but B upon A raised to m. Okay, so this is fourth result. A by B raised to minus m is nothing but B by A raised to m. Now see examples depends on above results. So here 3 raised to 4 divided by 3 raised to 6. So we know when base is same, then power gets subtracted. So here 4 minus 6. So here 4 minus 6 is what? Minus 2. Okay, and 3 raised to minus 2 is nothing but 1 upon 3 raised to 2. 1 upon 3 raised to 2 means 3 multiply 3 2 times, that is 1 upon 9. So here 3 raised to 4 divided by 3 raised to 6, its value is 1 upon 9. Okay, so see here, first of all base is same, so power gets subtracted. Our first property, A raised to m upon A raised to n is nothing but A raised to m minus n. Here we have written 3 raised to minus 2 as 1 upon 3 raised to 2 means A raised to minus m is nothing but 1 upon A raised to m. Okay, so we can use all these results. Now see second, 3 by 5 raised to 2 divided by 3 by 5 raised to 5. So we know whenever base is same, their power gets subtracted. Here 2 minus 5. So here 3 by 5, 2 minus 5 is minus 3, and we know how to write negative power in terms of positive. So 1 upon this 3 by 5 raised to 3. Okay, use this property again here. Now so here 1 upon 3 by 5 raised to 3. Okay, so you can write this also, means you can simplify such a types of divisions by using properties. So here see 3 by 5 raised to 2 divided by 3 by 5 raised to 5 is nothing but 1 upon 3 by 5 raised to 3. Now you can simplify. 1 upon 3 by 5 raised to 3 means multiply 3 by 5 how many times? 3 times. Okay, so 1 upon 27 upon 125, and we can write it as 125 upon 27. So we got values of this expression by using properties. Okay, so you can use all above properties to solve such types of examples. Again see one more examples. 4 is to 7 divided by 4 is to 5. So here base is same, power gets subtracted. Here we have used property A raised to m divided by A raised to n is nothing but A raised to m minus n. Again 4 is to 7 minus 5 means 4 raised to 2. Okay, so here we can simplify. You can find value also. 4 multiplied by 4, that is 16. Okay, now see second. P raised to 3 divided by P raised to 13. So here P remains same, 3 minus 13. By using this property, P raised to 3 minus 13 means minus 10, and P raised to minus 10 we can write it as 1 upon P raised to 10. Which property? A raised to minus m is equal to 1 upon a raised to m. Okay, so such are types of examples you can simplify. You can simplify and find values. Okay, so by using this property you can solve practice set number 27 and practice set 28. Okay, so try to solve these examples from this exercise. Okay, thank you.